best now. Hey.
Good day, guys. Welcome back to our YouTube channel, guys. So just like always, you know the vibe. Stiffler is me and me is Stiffler, guys. So today we're going to do sine, cosine, and area rule under trigonometry. When I started the trigonometry sessions, I mentioned that there is part 1 and there's part 2 and there's part 3, which part 1 mostly focuses on the triangles themselves, like the ratios and all that. And then part 2 now, it deals with these guys, a sine rule, area rule, and cosine rule. So part 1, basically, it's more of about the right-angled triangles. So this is more about the right-angled triangles. And then part 2 now, it focuses on triangles that are not right-angled, right? And then part 3 now focuses on the trig graphs, right? So now we are on part 2. So part 2 mostly just starts in grade 11 to deal with the sine rule, cosine rule, and area rule, right? But before I go there, let me just recap a bit on the things that we did in grade 10 so that you can be able to formulate the rules that you can use in grade 11 now, right? Okay, so let's get straight to it. So guys, in grade 10 we learned about the ratios, right? In grade 10 we learned the ratios. So we said if we're having a right-angled triangle like this, and this is our theta there, we know that this will be our hypotenuse, this is our opposite, and this is our adjacent, right? Where our ratios are defined as sine theta being equals to opposite over hypotenuse, cos of theta being equals to adjacent over hypotenuse, and then lastly tan of theta being equals to opposite over adjacent, something like that, right? So these are the stuff we're doing in grade 10, most of it, right? So these ratios, they help us to find any of the sides, right? Any of the unknown sides or unknown angles, right? So it means that you are required to have the angle or any other side to find another side, right? Or we are required to have two sides to find an angle, depending on the situation, how the situation is like, right? So this is what we're using in grade 10 work. So just remember that sine theta is equals to opposite over hypotenuse, cos theta is equals to adjacent over hypotenuse, and lastly tan of theta is equals to opposite over adjacent, right? So let's find a bit of example that we can tackle nyana before we can go deeper into this, right? So if we're having a situation like this, and they say we must find the value of h and the value of a, right? So according to this diagram, this is our angle there. So this is our opposite, our hypotenuse, and our adjacent, right? So we can say our sine of theta is equals to the opposite over the hypotenuse, which this is the sine of 69 being equals to the opposite, which is 24 over the hypotenuse as h, right? And solving the equation, guys, straightforward. This is h equals to 24 over sine of 69, where our h becomes what? So our h can become 25.71 centimeters, like that, right? And if we're trying to find a, then we can say our tan of 69 being close to the opposite, which is 24 over the adjacent, like that. So it means that our adjacent becomes 24 over 10 of 69. So it means that our A now becomes what? Our A becomes 9.21 centimeters, something like that. So these were the rules that we're using in grade 10, right? But now we're in grade 11, guys. So grade 11, our work deserves also grade 11 methods, right? So let's get to these rules a step after the other, right? Okay, so we're going to start with the sine rule. So we are going to start with the sine rule first, right? Okay. So guys, the previous work were just limited to right-angled triangles, right? To right-angled triangles. But now we don't have a right-angled triangles. As you can see, these angles, there's no any right angle. So what should we do? What should we do now? Should we cry? No, we don't have to cry, right? So it means that we can use either the sine rule or the cosine rule, right? So now I'm going to teach you how to prove the sine rule first. Then after proving the sine rule, then I can help you how to use the sine rule, right? Okay, so when we're trying to prove the sine rule, we can have our triangle like that. So this is angle B, this is angle A, and this is angle C, right? So this side that is opposite to angle B, let's call it side B. And this side opposite to this angle, let's call it side C. And now this side opposite to this angle, let's call it side A, right? So we can construct a height that is perpendicular, right? That is perpendicular, that is drawn from angle A to side A, perpendicular to it, right? So let's say maybe we're having point D there. That is perpendicular like that. So this is how you can prove if you're trying to prove this rule, right? Okay, so let's get straight to it. So we're going to prove in triangle A, B, D and triangle A, C, D. So we're going to prove in two different triangles. So it is this triangle that you can see there, and this other triangle that I didn't draw anything inside. Can you see that? Yes. So let's start. So in triangle ABD, so in triangle ABD, now we're having a right angle there. Can you see that? So we know that our sine of angle B, sine of this angle here, it is equals to opposite over hypotenuse. So let's call this height H, right? So it is equals to H over C. So this is equals to H over the side C, right? So after multiplying both sides by C, you can see that C multiplied by sine of B is equals to H, right? And also in triangle ACD now, in triangle ACD, we can see that this angle here, so the sine of angle C, the sine of angle C is equals to the opposite, which is H, over the hypotenuse, which is B. Can you see that? Can you see that if this is our right angle, then this becomes, if this is our angle and this is our opposite side, this is our hypotenuse and this is our adjacent. Can you see that? Yes. So now after multiplying both sides by B, now our B sine C will be equals to H. Can you see that? So this side is equals to H, and also this side it is equals to H. So both sides are equals to H. So mathematically, so if two sides are equal to the same thing, we can equate those sides. So it means that our C multiplied by sine of B will be the same as our B multiplied by the sine of C. Can you see that? So it means that we can happily divide both sides by BC and also this side by BC. So C and C can cancel, B and B can cancel. Can you see that? So now we'll be left with sine B over B. So sine B over B there will be the same as sine of C over C, right? So it means that in any given triangle like this, we are going to have situations like this, like sine of B over B, it is the same as sine of C over C, which is also the same as sine of A over A. So this is our sine rule. This is our sine rule. So it means that without a right angle triangle, we can use something like this, right? So let me give you a clear picture so that you can see clearly before we can do an exercise, right? Okay. So how do we use this sine rule? How do we use this sine rule? So already we said the side opposite to angle B is equals to B, the side opposite to angle A is equals to A, and the side opposite to angle C is equals to C. So it means that if we're having a situation like this side, this angle, it is opposite to this side, and this angle, it is opposite to this side, and also this side is opposite to this angle. So we are going to take the pairs of any information that is given, right? It is the one that gives us our formula, right? Or our equation. So it means that sine of this angle here should be over the side that is opposite to this angle. Can you see that? And also sine of this angle here, it should be over the side that is opposite to this angle. Can you see that? And also sine of this angle here should be over the side opposite to this angle there, right? So this is how you can use the sine rule, right? So you just take the side that you are required to find the solution, and also the pair that is having a lot of information as well, right? So let's just do a couple of examples, and then I'll give you a checkpoint to do, right? Okay. Okay, so now we are required to find the value of x, right? So this value of x, it is opposite to this angle, so we can take this pair, right? And also having this other angle that is opposite to this side, so we're going to take this pair and try to solve for x, right? So it will mean that the sine of 54 degrees, right? The sine of this over the opposite side, can you see? Over the opposite side should be equals to the angle sine of 35 over the opposite side that we're trying to find, right? So now we can manipulate this equation by doing this. 33 times sine of 35 over sine of 54. We cross multiplied and also multiplied by that to get rid of everything there, right? Can you see that? Yes. So the next thing now, it means that we can punch everything in our calculator and find that the value of x is 23.40 centimeters, right? Can you see that? So it means that this formula requires four things, right? So it requires a pair of a side and an angle that is opposite to it, right? So this requires a pair, two pairs actually, of a side and opposite angle, side and opposite angle, right? And now you can solve the unknown, right? But don't try to change the equation, right? Let the equation dictate what you should find, right? Don't try to change the equation, right? Yes. So let's try to do another example so that you can see how this works, right? Okay. Now we are having a different situation where we are trying to find the angle now. Can you see that? Now we are trying to find the angle, right? What should we do? Should we cry? No, 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 no. So we still do the same thing. This angle, it is opposite to this side. So that's a pair. And this angle, it is opposite to this side. So that's another pair, right? So we can happily find the unknown, right? So we know that sine of this angle x we are trying to find over the opposite side, which is 71, should be equals to sine of 52 over the opposite side, which is 68, right? So it means that our sine of x will be equals to 71 multiplied by sine of 52 all over 68 by what? By cross multiplication, right? And lastly, we can take sine that side. So it means that our x now becomes the second function of sine, and the 71 multiplied by sine of 52 all over 68, right? I like to punch my answers all at once so that I won't have to deal with the errors of rounding off a lot, right? So I'll punch everything all at once while they are rearranged like that, other than doing it single by single, because I'll end up rounding off the answers and then my final answer will deviate a lot from the answer, right? But if I punch everything at once, I'll just get straightforward answer, right? So the question is, are you able to do that? So I'm going to leave you with checkpoint 1 so that you can try to solve this on your own, right? And you know that I always bring the answers, right? So just for the length of the video, I have to cut this here, and then we deal with cosine rule, right? So like always, guys, if you haven't subscribed, please help us by subscribing, and also share and like this video, and also comment if you have other insight about this video, or if you want to share something with us, right? And again, guys, I've provided the link to our email address, so that if you are having any challenge, you can send us the questions on our email address, right? So see you on the next chapter.